Okay, let's look at the nth term test for divergence. And the hardest part of this test is that it only proves divergence. Right? This test, the nth term test, can only prove divergence. It can't prove something converges. The test is very easy to apply, and here's what it says. It says that if you have some series, the summation of some a to the n can be anything, right? So examples of a to the n, this could be 1 over n, this could be n plus 1 over n cubed, this could be 2 to the n over n squared, this could be n squared over 3n squared plus 5, any of these things, right? And what it says is this. It says that if you look at the limit of a to the n, meaning this guy, right? Look at that limit, look at that limit, and the limit as n goes to infinity, and it's not 0, okay? If you can show me that the limit is not 0, then you know for sure that the summation of that series diverges, meaning it's got an infinite sum. And that should be really easy if you think about it, okay? If you can show me that the last term, again, what are you finding here at the nth term test, is because you're looking at the limit of a to the n as n goes to infinity. So you're looking at the last term, right? The infinite limit is the last term in a series. So if you can show me that that isn't 0, then essentially what you keep doing then, you keep adding up an infinite number of finite things. Okay? Let's look at this guy as our example. Okay, that's kind of the poster child for it. If I gave you this series, the summation of n squared over 3n squared plus 5, and we could go from n equals to 1 to infinity, and we could look at that series, okay? So we could plug in 1, and we could get 1 over 3 plus 5, and we'd get 1/8 plus, plugging in 2, and these numbers are going to get big pretty quick. Plugging in 2, this would be 12, 17, 4/17, plus plugging in 3, then we're going to get 9 over, 27 plus 5, 9 over 32, plus ... Okay, and you're not really sure whether that converges or diverges, but we are, because look, if we look at the limit of n squared over 3n squared plus 5 as n goes to infinity, we know by L'Hopital's that that limit is equal to 1/3, which means that all of these terms are approaching the value of 1/3. So if I go infinitely far away, I get 1/3 plus 1/3 plus 1/3 plus an infinite number of 1/3s, because that's what the nth term is. And so it doesn't really matter how small this limit was, even if this was 1 over 300 or 1 over 3,000. If this limit was super small, you'd still get an infinite number of super small things. And again, and I don't mean something like 0, I mean some finite number. An infinite number of finite numbers is then an infinite sum. So this is infinitely big in terms of the sum, which means this diverges. Again, if you can show me that the last term is anything but 0, then you know the series diverges. However, do not do the opposite. This test will never, ever, ever, ever prove convergence. It can prove something diverges, but it will not prove convergence. As an example, just because, this guy's the poster child for it, just because you can show me that the limit of 1 over n as n goes to infinity equals 0, that proves nothing. Nothing, nothing, nothing. That doesn't mean anything. So we have to move on and do another test. Maybe you've already discussed that this does actually diverge based on the integral test or the p-series test. So this is an example of, even though this has a limit of 0, it diverges. Where if we looked at maybe the series 1 over n squared, of course it goes to 0. Okay, and again, I gave you two different examples. Both of these examples have limits of 0. However, this diverges based on the p-series, and this actually converges based on the same test, the p-series test. Again, showing me that you go to 0 actually is completely and utterly worthless. Showing me that something doesn't go to 0, meaning it approaches some finite number, well then of course, then I know it diverges. So this test is really just a divergent test. Divergent test. It only can prove divergence. It cannot prove. Okay? Again, you can use it to prove, since this goes to 1/3, that this infinite sum is basically doing 1/3, 1/3, 1/3, 1/3, 1/3, and this is infinitely big. It can show that this diverges, because we know that 2 to the n over n squared, that limit is infinitely big. So of course, summing up infinity an infinite number of times is infinitely big. But it does nothing for these two tests. Both of these have limits of 0. However, this one diverges and this one converges based on entirely different tests. So this test, sometimes you can just kind of look at it and boom, you know right away what happens. You know, maybe an example like, you know, n plus 1 squared over n squared. What happens there? Well, n equals to 1 to infinity. We know that this limit of n plus 1 squared over n squared, as n goes to infinity, this is an n squared over an n squared, so that limit's equal to 1. So what we know is eventually this a to the n is approaching 1, so eventually you keep adding 1 plus 1 plus 1 plus 1 plus 1. So we've shown that the limit is non-zero, thus we know that this is an infinite sum and we can claim that it diverges. Okay, so don't overcomplicate the nth term test. It's kind of a pretty easy test, but again, it only proves divergence, not convergence. Okay?